Let's see this question. We want to determine the second order of Taylor formula for this function about this given point. So remember, the second order of Taylor formula involves the function value at this point, then the first derivative at this point, and second derivative at this point. So we need to calculate f of pi comma 1, the function value at this point. So that's e raised by 2 times 1 cosine pi. Well, 2 times 1 is 2, so e raised by 2. Then cosine pi is -1, so we get negative e to the 2. That's the function value. Now we need to find the first derivative. So we need to find the partial f, partial x. And then we want to evaluate with pi 1. So taking derivative in terms of x, so get negative e to the 2y sine x. Then sine pi is 0. Right, so this value is 0. So we need to find the partial f with y in y direction. So the rate of change in y direction, right? Then evaluate at pi 1. So e to the 2y, that's 2, derivative is 2 times e raised by 2y. Then cosine x. So cosine pi is a -1, so we get negative value. Then y equals 1, so we get -2 e to the second power. So this is the first derivative. So then we need to find the second derivative. I'm going to find it. So take derivative of this one in x direction again, get the partial second order of derivative. So then we want to evaluate at pi 1. So which means we take derivative in terms of this one. Well, that's negative e to the 2y sine x. Right? We take derivative with x, sine x is cosine x. So get negative e to the 2y cosine x. And we evaluate at pi 1. So we get, so cosine pi again is -1, negative become positive. So this we get e squared. Then mixed partials. So let's take so take derivative of this one in y direction. We get a pi comma 1. Then we evaluate at pi 1. So take a derivative of this one in terms of y. So we get negative 2 e to the 2y sine x. And this one we evaluate at pi comma 1, sine pi equals 0. So we get this one to be 0. Now the third one we need, let me change to be red color. We need to find the second partials in y direction. Then we evaluate at pi 1. So we take a derivative of this in y direction again. In y direction, so we get a 4 e to the 2y cosine x. Then we evaluate at pi 1. So we get a, well, cosine pi again negative, so we get negative. We get negative 4 e to the second power, right? Y is 1. All right. And because the mixed partial are the same, so this one also equals to partials, second partial in this order, right? So if we take derivative of this one in x direction, and we get the same value. Now with all these values, we can plug in our formula. So let's write in blue color. So we want to evaluate, well, some, let's say x plus h Not really, not plus h, because we know this value in this case. Right? So we want to evaluate this about pi 1, pi comma 1. So we could do, what could we do is we could do pi plus some small value, right? Maybe we could call h1. Then 1 plus some small value, maybe you can call h2. So basically, we want to use this next point to approximate the function values, very close to this point. So that's why we use this notation. So first we have function value, the first term, which is negative e to the second power. Then involves us the first derivative. First derivative in x direction is 0. In y direction, we have this, so that's minus 2e squared multiplied by y direction. The difference we could write down as y direction. We could write down as h2, right? h2, or what's the better? Actually, what's the better one? Okay, we could write down as h2. So basically, the difference in y direction. Okay. So another way of writing it is just write down y minus 1. Y minus 1. Or because I write this in this term, where f of pi plus h1, then 1 plus h2. So I write h2. So difference in y direction. So that's first derivative. Right? In x direction, it's a 0. We don't get anything. Now, second partials. Second partials, we need to add a half. Right? Divided by half. So half of the second partials, which is e squared, then multiply by the difference. We can just write as h1 squared, h1 squared, right? Because the second partial is the second order. Now, the mixed partial is just 0, so we don't get mixed partials. Then plus negative, which is minus 4e squared, the second derivative in y direction. So that's h2 squared. And that's it. So one way we can write this way. Another way we can write it as, okay, we want to approximate some values around about pi and comma 1. And we could call x and y. At some point, it's about pi and 1. Then we can write this way. You can also write the function value minus 2e squared. Instead of writing h2, we can write as y minus 1. Then plus half e squared, h1 squared, which is x minus pi squared, minus 4e squared. Then h2 squared, h2 is y minus 1 squared. Right. We see every term has e squared. If we want, we can factor out e squared. But this is fine. Okay, so either one is good. As long as we know the definition of h1 or the definition of x and y in each case.